Hi, in today's video I would like to introduce a very nice problem of International Mathematical Olympiad edition 1960, question number 1. Okay, here is the following statement. Determine all 3-digit numbers n having the property that n is divisible by 11 and n over 11 is equal to the sum of the squares of the digits of n. Okay, in fact this problem is not hard, is not easy. It's more confusing because it's based on the question. Understanding the question, you may get the whole thing, you may get in the right direction. Okay, but failure to understand the question may not help you to get arrived to the solution. Okay, so let's get started. We are going to work on both properties. We have two properties. The number that we are going to find must be divisible by 11, and at the same time this result we are going to find, which is n over 11, equal to the sum of squares of these digits. Let's set is x, y, z. Okay, let's take, for example, these numbers may take 999. Okay, x is given, x we are given to x 9, y 9, and z 9. Okay, this is the maximum number this digit can take because these digits are running from 0 to 9. Okay, if you get more than 999, that means you are getting into the 4 digits, not 3 digits. Okay, so this number must be written on this form. N equal to 11 is multiplied by 10 p plus q, because n is divisible by 11. That means n equal to 11 is multiplied by something, but since we are working with the 100 digit and 10 digit and 1 digit, we must write it on this form. Because let's take, for example, p equal to 9 as a maximum number p can take. 10 is multiplied by 9 is 90. 90, let's take 9, q is 9, for example. So 19 plus 9, which is 99. 99 is multiplied by 11 is giving you 999. So wherever you replace p and q, this equation is verifying the statement. Also, this number can be written on the other form as well. For example, this one can be written as 100 is multiplied by x plus 10 is multiplied by y plus z. This term is representing 100 digits. This term representing 10 digits. This term is representing 1 digit. This one is giving us 110p plus 11q. Okay, I can write it as 100p plus 10 is multiplied by p plus q equal to 100 x plus 10y plus z. P and q is running from 0 all the way down to 9. The same thing with x, y, z. Okay, I have this number as n equal to this term, in the same time equal to this term. I will have here two cases, the case number 1 and case number 2. If we have p plus q is less than 10, okay, and if we have p plus q is bigger or equal to 10. Okay, every single number here, p or q, is taking the number from 0 to 9, but when you sum them together, it may be exceeded a number 10, because for example, if p equal to 9 and q equal to 9 is giving you 18. So if it's exceeded 10, it's not gonna stay here because it's considered as a 10 digit. It has to move on, it has to move over to the 100 digit. This one, it's placed as long as p plus q is less than 10. If it exceeds number 10, has to move on to the 100 digit. Okay, this is the most confused point here. So let's take this case first. This case, p plus q is less than 10. We have these numbers. I'm going to make the combination. We have p, we have x equal to p, as we have here, right? We have y equal to p plus q. and we have z equal q. Okay, so that's mean y equal to x plus z. For the second case, here is a problem. If this number, this sum p plus q, exceeded number 10, is not gonna stay here. You have to move on to the 100 digit because it has carrying digit here towards 100. Okay, so that's mean I will have x equal to p plus 1. For example, let's take that p plus q equal to 11. This 11 is not gonna stay here. One digit has to carry towards 100. So x equal to p plus 1 here, and y it has to equal to p plus q minus 10. Okay, because it's counted as a one digit. If you go to 100, we borrow minus 10 to the 100 digit. Okay, so for the z equal to q, so this one, that's mean y equal to p equal to x minus 1 plus z minus 10. This one equivalent, that's mean y equal to x plus z minus 11. Okay, now we found y equal to x plus z. If p plus q is less than 10, and we found y equal to x plus z minus 11 if you have p plus q is superior or equal to 10. Okay, now let's move on to the next board by doing two cases. Okay, first case, we have y equal to x plus z. I'm going to work on first expression. So I have n equal to 100x plus 10y plus z, 10x plus, I'm going to replace y with its value. I will get 10 is multiplied by x plus z is giving us 100x plus 10x, which is 110x, plus 10z plus z, which is 11z. So I will get n. I'm going to take 11 as a common factor. I will get 11 is multiplied by 10x plus z. It's equivalent. I'm going to divide both sides by 11. I get n over 11 equal 10x plus z. Okay, so this is the expression that I found. This number, now I'm going to work on the second property. As we said before, this number n over 11 is equal to the sum of the square of this digit. This digit is, that's mean this number equal to x square plus y square plus z square. That's mean this digit equal to x square plus y square plus z square. Okay, I'm going to replace y with its value because we found y equal to x plus z by matching the numbers. So n over 11 equal to x square plus x plus z quinary square plus z square. Okay, n over 11 in the same time equal to this one, 10x plus z. If you take a look carefully on both sides of this equation, let's consider x. If x 10x, this is even number because 10x, this is even, this is always even, whatever the value of x and z. Let's consider if x is a even and z is a even, that's mean even plus even is giving us even. That's mean even plus even plus even. So this term must be even as well. But if you have x odd and z odd, so that's mean x is odd plus odd is giving us even. Odd plus odd is giving you even. That's mean the whole thing is even as well. Whether if you have x and z, if you have both x and z even is giving you even, that's mean the right hand side of this equation must be even as well. If you have both numbers x and z are odd, That means the right side of this equation must be even as well. But in case if you have x is odd and z is even, if you have x is even and z is odd, x is even plus z as odd, which is giving you odd, right? X is even plus odd is giving you odd. Odd plus odd is giving you even. Whatever you write, you find these numbers are even. Okay, that's mean the right hand side of this equation even. Since this term is even, that's mean this term must be even as well. Okay, since z is even, is one digit, that's mean z must take these numbers 0, 2, 4, 6, 8. I'm going to check case by case. If z equal to 0, I'm going to replace z with its value in the first equation here. So we'll get x squared plus x squared, because this one is 0, plus 0. This one is giving us 10x because z is taking number 0. So equivalent 2x squared plus 10x, equivalent x equal to 5. Okay, now we found x equal to 5 and we found z equal to 0, and y, since we have the relationship between y, since y equal to x plus z, that's mean x will be replaced with 5 plus 0, which is 5. Now the numbers, now the digit number which we are looking for, x, y, z, equal to x is taking 5, y is taking 5 as well, z is taking 0. Okay, that's what we found. Now we found the first digit, but there are many cases after this one. So if you check all other cases, 2 and 4, 6, 8 are not working here. Okay, let's take this example, z equal to 2. Z equal to 2, I'm going to replace with z with its value. We'll get x squared plus x plus 2 quinary square plus 4 equal to 10x plus 2. Okay, now I'm going to simplify this one. I will get x squared plus x squared plus 4x plus 4, which is plus 8, equal 10x plus 2. It's equivalent. This one is giving us 2x squared plus 4x minus 10x, which is minus 6x, 8 minus 2, which is plus 6, equal to 0. Okay, I'm going to divide both sides by 2. I will get x squared minus 3x plus 3 equal to 0. Okay, equivalent. This one is giving us x minus 3 over 2 quinary square plus 3 over 4. This one is greater than 0. This is contradiction. That's mean because we have this one equal to 0, this one is greater than 0. That means contradiction. That means there is no solution. There is no solution for x equal to 2. Okay, so there is no digit number x equal to 2. If you check all other remaining cases, you find the same thing. You find the contradiction. That means there is no digit number for the following numbers 2, 4, 6, and 8. Okay, that means the only digit number that we have, which is x equal to 5 and y equal to 5, z equal to 0. Now let's move on to the case number 2. Okay, now let's take the second case when we have y equal to x plus z minus 11. Okay, I have n equal to 100x plus 10y plus z. I'm going to replace y with its value. I will get 100x plus 10 is multiplied by x plus z minus 11 plus z. Okay, so I will get n equal to 100x plus 10x, which is 110x plus 100, I'm going to split this 11 by 2. In minus 11 equal to minus 1 minus 10. I will get minus 10 is multiplied by 10. I will get minus 100. Okay? Minus 1 is multiplied by 10. I will get minus 10 plus 10z plus z. Okay? Take 110 as a common factor. I will get 110 is multiplied by x minus 1. 10z plus z is 11z. I'm going to divide both sides by 11. I will get here 10x minus 1 plus z. This one by using the second property, so equal to square of first digit plus square of second digit plus square of the 100 digit plus square of 10 digit plus square of first digit. Okay, so I'm going to replace y with its value. I will get x squared plus x plus z minus 11 quinary square plus z square. Okay, now we get n over 11 equal to 10 is multiplied by x minus 1 plus z equal to x squared plus x minus plus x plus z minus 11 quinary square plus z square. Okay, now if x and z are odd numbers, this means odd plus odd is giving you even. That means odd plus odd is giving you even. Even minus odd is giving you odd. That means this equation on the left hand side must be odd as well. Okay, but let's take another case. When you have x and z are even, x is even and z is even. That means even plus even is giving you even. Even minus odd, that means the whole thing is odd. That means on the left hand side of this equation is odd as well. Okay, so let's take the case when you have x is a odd but z is a even. Let's take x is a odd and z is even. That means odd plus even is giving you odd. Odd minus odd is giving you even. Here is x is a odd plus even is giving you odd. That means the whole thing is odd. Whatever you write, you find this term is an odd number. Since this one is odd, that means on the left hand side of this equation must be odd as well. Since this is even, because we have 10 is a even, is multiplied by any number here is giving you odd, is giving you even. Okay, that means this one must be odd. So since this one is odd and z is a one digit number, that means is running from is gonna take the odd numbers. So the z, it will take 1, 3 or 5 or 7 or 9. Okay, in order to find z as a digit number, we must check all the cases. Let's consider the first case. Okay, for the first case we have for the first case z equal to 1. Simplifies, I'm going to replace this 1 into this equation. I will get 10 x minus 1 plus 1 equal to x squared plus x plus 1 minus 11 quinary square plus 1. After simplification, this one is giving you, so by simplifying this one, I will get x squared plus x squared, which is 2x squared, 2x squared minus 20x plus 100 plus 1, which is 101. Okay, taking these two terms to the right hand side of this equation, I will get minus 10x. So this one is given as minus 10 plus 1, which is minus 9. By taking this minus 9 to the right hand side of this equation, become plus 9 equal to 0. Okay, so this one is giving us 2x squared minus 20x minus 10x, which is minus 30x plus 1 plus 9, which is 120, plus 120 equal to 0. By dividing both sides by 2, I will get x squared. I will get here 15. I will get 60. Okay, this one is giving us x minus 15 over 2 quantity square plus something, okay, which is positive. This one will be strictly superior than 0, which is impossible. That means there is no digit numbers for z equal to 1. Let's check the remaining cases. So let's check z equal to 3. Equivalent, by replacing z with its value, I will get 10 x minus 1 plus 3 equal to x squared plus x plus 3 minus 11 quantity square plus 9. Okay, 3 minus 11 is minus 8. I'm going to simplify this one more. So by simplifying this one, I will get x squared plus x squared is giving us 2x squared minus 2 times 8, which is minus 16x, okay, plus 64 plus 8 quantity square plus 64 plus 9, which is plus 73. Okay, by moving these two terms around, I will get 2x squared minus 16x minus 10x, which is minus 26x minus 10 plus 3, which is minus 7. By moving this minus 7 to the other side, become plus 7 plus 7 plus 73, which is plus 80. Plus 80 equal to 0. Okay, by dividing both sides by 2, I will get x squared minus 13x plus 40 equal to 0. Okay, when you calculate this one, you find x minus 5 is multiplied by x minus 8 equal to 0. Okay, there is 2 roots here. 5 is not solution. When you replace x with 5, you find 5 plus 3, which is 8. 8 minus 11 is minus 3, which is impossible. So there is no solution, there is no digit number with x equal to 5. Now x must be equal to 8. So x equal to 8, z equal to 3. That's mean 8 plus 3, 11 minus 11 equal to 0. That's mean y equal to 0. That's mean the digit number. So the second digit number xyz equal to 8 or 3. Okay, as a digit number. So in order to find other digit numbers, when you calculate 5 and 7 and 9, you find a contradiction. That's mean there is no digit number. The only digit number that we have 803 and 550. Okay, 550 and 803. This is the only digit that we have. Okay, now we have done with this problem. Just consider subscribe. If you have any questions, just put it in the comment section below. Thank you for watching. I will see you in next video. Bye.